بسم الله الرحمن الرحيم رب زدني علما.
So now the main difference, as we already discussed, the GLBP offers you the load balancing option, which is not available in the previous one, which means for the same network or the same subnet or for the same VLAN, all the gateways will be forwarding the traffic at the same time. Now, there are three different variations or three different options we can say the load balancing can be done. Okay, so either we can use round robin fashion, or we can use the weighted, or we can use the host dependent, whichever you want. Let's try to understand the each method a little bit in detail to understand how they exactly do. So the first one, I start with the round robin load balancing method, which is going to be the default method again. So if I don't enable or if I don't change the load balancing mechanism, the default method will be the round robin method. Now, how this is going to work, I'll take the three gateways. Three will be sufficient. You can have up to four. I'm going to take this diagram, router 1, router 2, router 3 will be acting as my three gateways. So all these three gateways will be forwarders. Like I said, all will be forwarders. Any one will be the AVG. We already discussed that, how it works. So now here what will happen, let's take an example. There are three different hosts, the client A, client B, and client C, or PC1, PC2. Let's take the same names, ABC. So the ABC, so let's say that A sends a request, ARP request. So who is going to listen to the ARP request? Of course, the AVG is going to listen to the ARP, reply and respond with the MAC address of the router 1. So which means the client A, when it sends an ARP request, it will send the MAC address of this. So which means most likely the client A will use the router 1 as a gateway. And when the client B sends a request, the same thing, the client B will be sending using the second gateway, and the client C will be using the third gateway. And likewise, if you have a client D, let's say one more, it will be using again the first one. And if you have another client, let's say client E, it will be using the second gateway, and then F will be using the third one. Likewise, the same thing, the round robin is nothing but every gateway will get an equal chance to forward the traffic in a sequential manner, where each PC will receive a different MAC address. Like the A, when it sends, it receives the MAC address of this one, R1. When the B sends a request, it gets the MAC address of the router 2. C sends a request, the MAC address of the router 3. And when the D sends a request, again, it is getting the MAC address of, again, router 1, again 2, again 3, like that. So everything goes in a sequence. Okay. So we call this as a round robin fashion, round robin load balancing, which is a default. If you want to change, anyway, the default is same. This is a command to change the load balancing mechanism. If you want, we can choose from any one. As I said, the best thing about the round robin is it will ensure that equally the load is distributed across all the gateways, which is more important if you have the same processing routers. Let's say all the gateways are the same capability. They all are having the similar kind of hardware and almost the similar kind of WAN connections. Like all the links are using 50 Mbps links, 50 Mbps, 50 Mbps. So if all the WAN links are of the same speed and all the routers are of the same capacity, and you just wanted to do the load balancing equally because all are equally capable of doing that, then the round robin is the best option you always go with. Okay. So like uniform traffic pattern or uniform configurations, that is where mostly the round robin is more applicable, which is the default. But there are some scenarios where the round robin might not be applicable or might not be applicable. Like if you take a same example, you have a one router or one link going to the ISP is using 100 Mbps bandwidth, the speeds, whereas the compared to the other links, let's say on this link I'm just using 50 Mbps of link, and the other link, the third link, because I don't want to get more bandwidth and it is in idle state, not forwarding anything. So that's the reason what I did. I optimized the cost and use some different speed links. Let's say 100, 50, and 25. So if you compare the ratio, this is like 1. If you take this 1 ratio, this is like double of that. And this is 4 times of the first one. So 4 times. So as per this ratio wise, if you take them in the ratio part, as per this bandwidth, I expect that my router 1 will be sending 4 times more traffic than the router 3. And I'm expecting the router 2 will be sending 2 times more traffic than the router 3 compared to the bandwidth, or even mostly the gateway speeds will be similar. There is no much processing gateways, but mostly the one of the main reason where you want some gateways to take the more load or some interfaces to forward more traffic. In that scenarios, I can go with something called weighted load balancing mechanism. So in the weighted load balancing mechanism, we are distributing the traffic. We are distributing the traffic based on the weights, which means I'm going to configure the weight on this. Let's say I'm going to give the weight as 25, roughly. It will be like multiples of 100, let's say. Let's say the weight I'm giving 100 here, which is sending. Now I'll reduce this to half because compared to 4, this is exactly equivalent to half. So I'm going to assign the weight as 100 here. I'm going to assign the weight here as 50, and I'm going to assign the weight as 25. Okay. Now, as per this ratio, the router 3 will be sending 25% of the traffic, whereas compared to the other things like this will be sending. Now you can divide the ratio percentage. You can just calculate roughly. In terms of this percentage, you can see this is the ratio wise. So which means in short, we can say like the router 3 will be, let's say if the router 3 is sending 1 packet, the router 2 will send 2 packets, and the router 1 will be sending 4, which means maybe the 4 host requests will go from here, 2 gate host requests go from here, and 1 host request will go from here. Okay. So based on the weight, like in this case, you can say like if I divide the same thing in 1 to 4 part as per the weight, most likely, let's say A will go from this side, B and C will be assigned this gateway, and probably the next 4, let's say D, E, F, G, will be assigned with this gateway. So that's how the load is distributed. Additional PCs will follow the same ratio. So the more PCs you add, again, they will follow the same ratio like GH. H will again use this one, and the next 2 will use the next gateway. So this is more applicable where you want a specific gateways to carry more traffic, where you have unequal distribution. Like I said, the best example, like I said, 100 Mbps of bandwidth, 50 Mbps, and then 25 Mbps. So that is one option. And the third option we also have. Now, again, as I said, this one weighted, you can also do based on the performance of the router, like the CPU and the memory capabilities. Also, you can also decide if you have a different routers with the different capabilities or the different speeds. That is also another factor you can consider apart from the bandwidth. But the majority of the scenarios, the bandwidth will be the deciding factor. Now, coming to the third option is the host dependent load balancing. Now, the host dependent load balancing is not based on this round robin or like that. It's similar to round robin, we can say. Now, in the case of host dependent load balancing, what happens is every client, let's say there is a client A, B, C, D, E, F. Let's say we have these clients, 6. Each client will be mapped with a specific gateway, the same virtual MAC address all the time, whenever they want. Which basically means that the client A, let's say, first time it uses this gateway, and every time it uses the same gateway every time. And let's say the B uses this gateway, every time the B uses the same gateway. C, let's say if it assigns this gateway, every time it uses the same gateway. Now, this is different than the round robin, because if you see the round robin fashion, if I go with something like this, if A sends, it will go to router 1. If C sends, it will go to router 2. If the F sends, it will go to router 3 like that. That is the round robin fashion. Means it will just assign the gateways irrespective of what the client address is. The next request will again go to router 1. That's a round robin fashion. But whereas here, the specific gateway like A is mapped with router 1, B is mapped with router 2, C is mapped with router 3. Not exactly mapping. It's like first time whichever the MAC address given. So that MAC address is like binded with that particular gateway. So same virtual MAC address will be assigned for every time A sends a request. Every time the reply or the AVG says, always the router 1 will be forwarding the traffic. So this is mainly applicable for specific application based kind of traffic. Like there are some applications, if you're using different gateways, then there is a possibility that that application might disconnect or might not work. In that kind of sensitive kind of scenarios, it can be mostly like VoIP based or any kind of financial transactions. If there is a change in the gateways, those applications might not work as per that. So if you have this kind of requirement where a specific application based gateways you want to assign, means application specific, where every time it has to use the same virtual MAC address and that virtual MAC address should not change, then the best load balancing mechanism you can go with around the host dependent one. Okay, so three different load balancing mechanisms are used in three different scenarios. Now, if we don't do anything, the default, as I said, it is going to be round robin. But as I said, if you want to apply the different weights on different links, you can use weighted. Or if you have any specific application based requirements, you can go with the host dependent options. Okay, so if you just summarize these three options, like I said, round robin equally distribute between all the gateways, whereas the weighted will balance the traffic based on the weight, like more or less. That's something it is going to do. And the host dependent, it just based on the host. Okay, whichever the host is binded, it's a fixed path. We can say fixed gateway all the time. Okay. So when we use round robin is the default where you just want to load balance between all the gateways equally. And the host dependent is more applicable when you have any application requirements, like there are specific application sessions, there are many things related to that, VoIP or financial applications. Weighted is more applicable when you have a different bandwidth speeds. Now, how to change? One line command, again, whichever the interface you are implementing, we need to go to that interface. Simply go to the interface and change the load balancing mechanism. Okay, that's what we have to do. Just change the load balancing. If you don't change, default will be a round robin